Okay, so what we're going to look at are the problems on page 2. We're going to work through the practice problems together. So what we're seeing here are the same types of problems that I went through in that video for your notes. We're going to work through, again, some examples together here on page 2. So we've got our problems in this table up at the top, and then we can check our work with this answer bank down at the bottom. As long as I find my answer down at the bottom, I know I've done my work correctly. So as we take a look at our first problem here, we have one polynomial plus another polynomial. The only reason these are in parentheses are so that we can differentiate. Here's one polynomial, here's another. There's nothing special about the parentheses here because I'm not multiplying, I'm adding. So all we're going to worry about is combining like terms. So that means we're going to combine the n cubed terms. So that would give me 2 plus 5 would be 7n cubed. And then we'll combine our constant terms. So 4 plus 2 would be 6. So 7n cubed plus 6. If I hop down to my answer bank here, I should have an answer, there it is, of 7n cubed plus 6. I don't care so much about us putting the letter here, but it is a good way to be able to double check. For number 2, same idea, but this time we're subtracting. Anytime we're subtracting, I see some like simple mistakes just based on that we forget that we're subtracting. So anytime that we're subtracting, I change the signs for whatever we're subtracting. Otherwise, it's very easy to forget that I'm supposed to be subtracting as I go through and combine like terms. So I'm going to write this as minus r to the 4th and then minus negative 5r cubed. And then that minus the negative we know is really addition. So now I'm going to combine my like terms. I'm starting with the term that has the highest exponent. That's the degree of my function. That was in your notes that you should watch last night. So that I can write my answer in standard form right away. So I start combining like terms with whatever has the biggest exponent. So that would be my r to the 4th term. So I've got 3r to the 4th minus r to the 4th. That leaves me with 2r to the 4th. And then I've got 4r cubed plus 5r cubed. That would give me 9r cubed. And then this is actually answer C down from the bottom. Questions for me so far? I would like you now to try number 3. Try number 3. Since this is subtraction, whatever term I'm subtracting, I'm going to change the signs on all of those pieces. Again, it's very easy to forget that I'm subtracting as I'm picking out those like terms to combine. That's why I rewrite it with those signs changed. And then when I actually combine my like terms here, 5a minus 5a means I have no more a's. Those are gone. And then I've got 4 minus 3. That gives me 1 for my final answer here. Number 4, we're subtracting again. This time our polynomials are a little bit longer. We've got 3 terms here instead of the 2 terms that we worked with for those first 2 problems. But I treat this exactly the same way. I'm just looking at combining like terms. Number 4, since we've got subtraction, again, I'm going to rewrite that polynomial that I'm subtracting with the signs changed. So this would be plus 6n to the 4th plus 3n plus 8n to the 5th. And now I'm going to combine my like terms. So 8n to the 5th minus 6n to the 5th would give me 2n to the 5th. Negative 8n to the 4th plus 6n to the 4th would be negative 2n to the 4th. This is my only n term right here. I have nothing to combine it with, so I just have plus 3n. And then here's my only constant term. So I'll have plus 3 at the end. So my final answer is 2n to the 5th minus 2n to the 4th plus 3n plus 3. Questions for me so far? I would like you guys to try number 5. Okay, so a lot of good work as I walked around. Remember, with addition, we don't need to rewrite. We can jump straight to combining our like terms. So my greatest exponent is 3, so I'm going to combine the r cubed terms first. So 9r cubed minus 2r cubed would be 7r cubed. And then I've got 5r squared minus 8r squared, that would be minus 3r squared. And then I've got 11r plus 9r, that would be 20r. Couple more problems to go here. 6 and 7 are really similar to what we just worked on, 6 in particular. So we're adding again. That means I'm just combining like terms. Remember, like terms are things that have the same variable and the same exponent. Okay? So this would be negative 7x to the 5th plus 5x to the 5th. I would have negative 2x to the 5th. And then notice as I'm combining these like terms, it's only the coefficient that changes. That exponent doesn't change when we're adding and subtracting. Next would be my x to the 4th. And this is my only x to the 4th term. So this would be plus 10x to the 4th. I don't see an x cubed or an x squared term. So next I'm going to combine the x terms. So minus 2x plus 7x would be plus 5x. And then finally I have a constant term of 14. That's my only constant term, so I don't have anything to combine that with. For number 7, again, I'm combining polynomials, but this time my terms have more than one variable. So I've got x's and y's in here. I'm going to treat this exactly the same way by combining like terms. I just have to make sure I match up both the x and the y exponents for my like terms. And then since this is subtraction, I'm going to write that piece that I'm subtracting with the signs changed. So this would be plus 6x squared plus 7x cubed y squared plus 4x. Remember, the subtraction is going to change my signs. For our previous problems, I also worked from the largest exponent down to the smallest exponent, or my constant term. Where I have multiple variables, we don't need to worry so much about standard form. If the x is cubed but the y is squared, should that go ahead of if the x is squared and the y is? That is not something that I want you guys to worry about. So for a problem like this where I've got x's and y's, I've got multiple variables, don't worry about standard form there. So my first term here is an x squared term. I've got another x squared term here, so I'm going to combine those. 4x squared plus 6x squared would be 10x squared. And then my next term here is x cubed y squared. I have an x cubed y squared term here as well, so I can combine these. Notice that my variables match, x cubed y squared. If they didn't match, these would not be like terms. So this would be 7 and 7, which is 14. So plus 14 x cubed y squared. And now I'm out of terms here, but I do still have this 4x left. So plus 4x. There are no like terms to combine it with. So just like our 14 from the last problem, goes at the end. Questions on number 7. That one was a little bit different. Our last problem on page 2, number 8, we're again adding and subtracting polynomials, but this time we actually have 3 polynomials that we're adding and subtracting. This doesn't change how I approach the problem. I'm still combining like terms. So again, I'm going to start with the piece I'm subtracting here, changing those signs. So minus x to the 4th y cubed minus 6x to the 4th y to the 4th. So I've rewritten this piece with the signs changed for my subtraction. And now we'll combine like terms. The first term I see here is a y cubed. I've got another y cubed here. So I'm going to combine those. Y cubed plus 6y cubed would be 7y cubed. And now I've got a term that has x to the 4th, y to the 4th. This has x to the 4th, but y cubed, so that's not a like term. This has x to the 4th, y to the 4th, so these are like terms. And then as I look at my third piece here, I've got another x to the 4th, y to the 4th term. So I'm going to combine all 3 of these. So minus 7 plus 4, that would put me at minus 3. And then minus 6 would get me to minus 9. So minus 9, x to the 4th, y to the 4th. The next term I see is an x to the 4th y cubed term. And I've got one other term left that's also x to the 4th y cubed. So I'm going to combine these. Negative 10 and negative 1 would be negative 11 x to the 4th y cubed. Questions for me for today? So the next thing we're going to do is an assignment. It'll sort of operate like a quick check that's posted for you on Delta Math. As you're working on Delta Math, please leave your notes out. You can use them as you work on your assignment, and I'm also going to check them for your first notes. So I'm going to look to see that you took your notes on pages 1 and 3. Okay. So your assignment is posted and available to you on Delta Math. You can use your own device or one of my Chromebooks if you would prefer. And it is due by the end of the class period. You should be able to complete problems just like this, adding and subtracting polynomials, due by the end of the class period.